Hello, Algebra 2 and Pre-Calc students. We are here to talk about rational expressions. Notice expressions, not equations. No equal sign involved. But starting out when we're talking about rational expressions, the first thing we usually talk about is simplifying them. The next thing we generally talk about is multiplying them. And then after that, we always like to talk about dividing them. So this video is sort of an intro to that process for my students who are going to start. This is a Friday, and on Monday they are going to start doing this, and on Monday we're going to get into all of this, but today we're just mainly going to look at simplifying and then multiplying. And with all of these, when you do all of these things to rational expressions, one of your main goals in trying to simplify them, and that's really what you're doing here. You've got multiplication going on, but you want to simplify it after you multiply. Or the multiplication is part of the simplifying process. But one thing you'll hear me say a lot when we're doing these: factor, 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 cancel, 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 because that's going to be the key to getting it done well. Okay, so let me just start out. I'm going to start with some super basic stuff because all of this pretty much goes that way. In other words, let's say I have, 12 21sts. Now that's a rational expression. First of all, rational expressions, usually when we say that, we're talking about variable expressions, because here we probably just call it a fraction. But rational, remember the word rational means basically we're generally talking about a fraction, ratio. That's where rational means. Rational technically means something that can be written as a fraction. Most of the time when we're saying rational, we are writing it as a fraction. So here's a fraction, just two numbers, no variables. If I want to simplify this, I take something that can come out of both 12 and 21 and I get rid of it. But what that really means I'm doing is this. It means that I am factoring 12 as, for instance, 3 times 4. And factoring 21 as 3 times 7. Now, there are other ways I could factor 12. Yes, I could call it 2 times 6 or something like that. But the point is, I was thinking, what goes into both of these? 3. So this is 3 times 4. This is 3 times 7. And then we cancel. So factor, 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 cancel, cancel, cancel. That's how we reduce a fraction. That is how we simplify something that is rational, even if it's just numbers. But we're going to get more into doing it with variables. So let's look at some simple cases with variables. Let's say that you have 3x over x plus 7. Okay? Now, for me to be able to simplify that, I have to be able to factor the numerator and factor the denominator and then be able to cancel the same thing out of the numerator and denominator. Because remember, canceling, really, all you're doing is you're calling this a 1. This makes 1, so 1 times 4/7 is just 4/7. Here's the deal. There's nothing I can take out of the entire numerator and the entire denominator here. If instead it was, let's say, this, okay? Now I could say, okay, I see that 3 goes into all of these things. I'm a little attached to 3 right now, apparently. So this is 3 times x on top, and in the bottom it's 3 times 2x minus 5. So if you want something factored, if you want it in factored form, when we say factor, 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 I'm saying get it to where it's a product of factors. Okay, write it as a product of factors. And then, sure, you can separate this. You could say 3 over 3 is 1. So my answer here is just x over 2x minus 5. I can't simplify that any further. That's it. Can't do anything else. Same thing here. This can't be simplified. Stop here. Very common errors on this. People want to take, let's say, it's a very similar situation. Like here. Here's a good example. People want to look at this and go, oh, look, x's will cancel. No, I can't take an x out of the entire denominator, so it's not a factor of that denominator, so I can't cancel it with x that's in the numerator. I can't do it unless it's a factor. If I have x plus 6 over 10, I cannot say That's x plus 3 over 5 because I'm taking out a 2. Because I can't take a 2 out of that x. Can't do it. Nope. I would just have to say I'm done. All right, I could rewrite it as a fraction and then, excuse me, as a sum of two fractions and then simplify one of the fractions, but that's not the point we're making here. And that's not necessarily much simpler. So let's look at another one. Here we go. How about 21n over 6n minus 3? All right. Can I factor the top, factor the bottom into some factors where there is a common factor? Sure. Common factor would be 3. Here we go again with 3. We're having a banner day with 3. So the top is 3 times 7n, and the bottom is 3 times 2n minus 1. Now I could take it out. Another way I've heard people talk about this is you can't cancel something out if it's tied to the numbers or variables next to it by addition or subtraction. In other words, this is just times. Times is fine. I've heard some teachers say that a plus or a minus is like a marriage. These are married, so we can't separate these two. We can't go ahead and this x can't go out with this x because it's married over here. So that's, if that's something that helps you remember it, great. Use that. A plus or a minus is a marriage. You can't break them up. Let's try another one. How about 35x minus 20 over 30? Well, thinking about what goes into 35 and 20 and 30, I'm pretty sure 5 goes into all of them. So I'm going to take a 5 out and say that's 5 times 7x minus 4 on top, and in the denominator it's 5 times 6. So it's just 7x minus 4 over 6. I cannot reduce the 4 over 6. Okay, what would I want to take out of 4 and 6? I'd want to take a 2 out, but there's no 2 that comes out of 7. So I'm stuck. That's it. I'm done. All right, so it's all the same principle we're really using up here, even though we don't necessarily think about that. When we simplify 12 over 21, we don't necessarily think about writing it as factors. That's the same idea. That's exactly what we're doing. So let's see if we can make it a little bit more interesting. How about if I had this? Well, again, if I can separate this numerator into factors, or separate the denominator into factors, where one of those factors would be the same, I could cancel. So that's the first thing I have to do is factor, so I can see the factors and tell, do I have a common factor in both the numerator and the denominator? So factor, factor, factor. That is my first plan. First step always with rational stuff. So I'm going to factor. And I said always, 95% of the time, maybe 90% of the time, but most of the time you're going to factor first. So how can I factor this? Well, m squared plus 2m minus 24. If I can come up with two numbers that multiply to give me negative 24 and add to give me 2, like for instance, how about 6 and negative 4? Do I have the same factor in the numerator and the denominator? I do. M minus 4 up here, m minus 4 down here. Boom, my answer is just m plus 6. What happened to the m minus 4 in the denominator? Remember, when you have something over itself, that's a 1. So now we have a 1 in the denominator. It's really m plus 6 over 1. Do we have to write a 1 when it's in the denominator? No. So I'm not going to. There, I'm done. What if it's r minus 9 over r squared minus 7r minus 18? Well, this can't be factored. R minus 9 can't. But let's see if this can. Always start by trying to factor. Two numbers that multiply to give me negative 18 and add to give me negative 7. R minus 9 and r plus 2. Okay, cancels. What's left when everything has canceled? What's left? A 1. 1 over r plus 2. Now, if you know that you are working with rational expressions and that you're going to factor, 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 and cancel, 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 that can actually help you factor. If I was stuck factoring m squared minus 2, plus 2m minus 24, or if I were stuck factoring r squared minus 7r minus 18, the first thing I would check is, does r minus 9 go into it? Because if they're asking me to simplify it's a fair bet that it does. Not always. Sometimes it can't be simplified. But if that's what I'm trying to practice, it's a pretty decent chance that if I can break this up into anything, r minus 9 might be one of those things. or this might get broken into m minus 4 times something else. So that can be a hint for you. Now sometimes you'll see them already in factored form, especially, let's just go ahead and do one like that. Let's say we've got, let's do this. There we go. Let's say it's already factored for us. Well, the only thing I can cancel here is m minus 3. And so then you could maybe leave it factored. It depends on the situation. A lot of teachers would let you just leave this factored, especially since it came to you factored. Now, let's talk about multiplication, because really that's just adding one little thing. Let's go back to the basics first again. Let's suppose that I am multiplying 2/3 times 4/5. How do we multiply fractions? Well, the way we multiply fractions is top times top, bottom times bottom. We don't cross multiply. That's not something we do to multiply fractions. Cross multiplying is something we do when we have a proportion. In other words, two fractions with an equal sign in the middle. That's when we cross multiply. That's not what's happening here. So don't think, oh, I cross multiply. No, we are multiplying two fractions, and the way we do that is top times top becomes the new numerator, and bottom times bottom becomes the new denominator. Okay? Let's suppose, new piece of paper here. Let's suppose I have, oh, I don't know, how about 2/5 times x over 3 times, oh, I don't know, let's go with 1/4 and 6 over y. It doesn't matter how many fractions you're multiplying, you're really just doing top times top times top times top. You just multiply all the way across the top. In other words, really, you could think of this as everything that's on the top is going to end up on the top all multiplied together. Everything that's on the bottom is going to end up on the bottom all multiplied together. You could kind of think of it as one big fraction bar. 2 times x times 1 times 6 on top, 5 times 3 times 4 times y on the bottom. Okay? So 2/5 times 10/13. If I am multiplying that, that's just going to be 2 times 10 on top and 5 times 13 on the bottom. So just like I could simplify 10 over 5 to be 2 over 1, I can do that here too. 5 goes into 10 twice and into itself once. So what you might be thinking of when you think of cross multiplying is actually cross canceling. The point is, since everything in the numerator is all going to be on top and everything in the denominator is all going to be on the bottom, anything on top can be simplified or reduced with anything on the bottom. So in other words, I can look at this 10 and think, oh, that's 5 times 2, so let me go ahead and cancel these 5s. And I get 4 over 13. And again, after I've done my simplifying, I just go straight across the top, becomes the numerator, straight across the bottom becomes the denominator. If there's nothing there anymore, it's a 1. Okay? So for instance, one more numerical example. 4/9 times, let's see, 21/10. Okay? Let's do it again. Let's do, how about times 2/6. Now, obviously that could reduce, but bear with me. 2 goes into 4, 2 goes into 10. So 2 goes into here twice and into here 5 times. Okay? 3 goes into 9 3 times and into 21 7 times. And I could also do it top to bottom. 2 goes into here once and into here 3 times. So on top I have 2 times 7 times 1, which is 14. And on the bottom I have 3 times 5 times 3, which is 45. Now if I had not cross-canceled, which I know you're thinking, okay, some of you are thinking, that's too complicated for me. I'm just going to multiply everything across the top and everything across the bottom and then cancel at the end. Sure, with numbers. But when we get to doing it with variables, you need to understand how to be able to do this. So if I had done this, like looking at just the blue writing, pretend I didn't do any of that canceling. 4 times 21 is 80, 4 times 2 is 168. 9 times 10 is 90, times 6 is, I'm looking for a calculator, so it's distracting me, 540. I was hoping I had a multi-view calculator for me, which would simplify for me and I could show you, but you're going to have to take my word for it that this is going to simplify to 14/45. Let's see what goes into there. It looks like 12 goes into both of these. 12 goes into this. This is 12 times 14. This is 12 times 45. So the 12s cancel and I have 14/45. Okay, so I can cancel beforehand, like I did up here, or afterwards. But the point I wanted to make to you is that because when you multiply fractions, everything on top all ends up being on the numerator, and everything on the bottom all ends up being multiplied on the denominator, you can cancel things that aren't directly on top of each other or on bottom of each other. Okay, so for instance, let's suppose I have I'm using a problem that is similar to the one you guys are doing for your assignment, but I'm modifying this, and I'll show you in just a second how I'm modifying it. Okay, so I can cancel things not just top to bottom here, but anything that's anywhere on the top with anything that's anywhere on the bottom. This one, the factor part was already done for me. If it's already been factored, I'm ready to cancel. So I can take this and I can say, well, k plus 5, k plus 5. K minus 2, k minus 2. 2 and 2. On the top, the only thing left is k plus 8. And on the bottom, nothing, which is a 1, which means I don't have to write it. I do have to write it if it's in the numerator. I don't if it's in the denominator. And that's it. So after I factor, everything on top can be canceled with anything on the bottom, and then I go ahead and multiply if there's anything left to multiply. Everything on top just ends up on the top, everything on the bottom ends up on the bottom, all next to each other. Let's do another one like that. Let's look at a more complicated version. How about x squared plus 12x plus 32 over x squared plus 2x minus 8 times x squared plus x minus 6 over 4x plus 12. Okay, so we have a lot of factoring to do. First step, factor. Now, one thing I like to do is I like to go ahead and write the factored form right above here. So this one is going to factor 4 times 8 makes 32 and adds to give me 12. So this is going to become 4x plus 4, x plus 8. This one, 2 times negative 4, positive 4 times negative 2 is going to work. Positive 4 times negative 2 gives me negative 8. 4 plus negative 2 gives me positive 2. This one we have, let's see, positive 3 times negative 2, gives me 6, gives me negative 6, and positive 3 plus negative 2 gives me the 1 in front of this. And finally, 4 comes out of both of these, so that leaves me with 4 times x plus 3. Now that I have it fully factored, I'm ready to do all the canceling that I can. Any canceling I can do. So I see an x plus 3, an x plus 3, cancel. X minus 2 here, x minus 2 here, cancel. You don't do any canceling if it's on the same level. If you have the same thing on the same level, no canceling. One has to be in the numerator, one has to be in the denominator. All the way across. X plus 4, cancel. All that's left in the numerator is x plus 8. All that's left in the denominator is 4, and these guys cannot cancel because I can't take a 4 out of this entire expression. The 8 is married to the x. We can't break them up. And that's my answer. Okay? 2 little things I want to talk to you about. One is this. If I have fractions that have variables in the denominator, I really should point out that I have domain restrictions. Go back and pretend I didn't cancel and you could still see through the x. K minus 2 would become 0 if k was what? K plus 5 would become 0 if k was what? We can't have k be those things because that would make everything 0. If you're multiplying straight across, if one of your factors becomes 0, everything's 0. So here I'm going to say, comma, this is my answer, and then comma, state my domain restrictions. k is not equal to 2 or negative 5. Because if k was equal to 2 or negative 5, we'd have a problem. So that's called stating my domain restrictions. On this one, I've got several. K can't be negative 4 because that would make this factor 0. K can't be 2, I'm sorry, we don't have k's. X can't be negative 4, X can't be 2, and X can't be negative 3. So really in my answer, I would say X not equal to negative 4, negative 3, or 2. Okay? The one last thing I want to point out to you is this. When I looked at the sheet, the problem here in blue, it didn't actually look like that. Let me show you what it actually looked like. I changed it because I didn't feel like we needed to do this quite yet. But now that you've seen one, I'm going to show you one more little thing that sometimes happens. Do you see what's different? Look at this factor, and look here. It was actually backwards, 2 minus k, which is not the same thing as k minus 2. So I cannot cancel these guys. I cannot right now cancel a k minus 2 with a 2 minus k. Not okay. No pun intended. But here's what I can do. If I have something I think I might be able to cancel, if only I could turn it around, and usually we're talking about subtraction with this, or like always. Okay, if I have a binomial, 2 terms, subtraction, and it's like, oh wait, I would love to cancel these guys, but one of them's backwards. Keep in mind that 2 minus k is the same thing as negative 1 times k minus 2. Okay, in other words, 2 minus k, if I took a negative 1 out of that, that would be negative 1 times negative 2 to get this, and negative 1 times positive k. And I can rewrite that. If I have negative 2 plus k, I can rewrite that as k minus 2. So if you have a subtraction expression, 2 terms, that you want to turn around, basically you can take out a negative 1 and now you can turn it around. The negative 1 would still be there, so don't forget about that. Even if you cancel everything out, if you don't cancel that one out with a negative 1 that's in the denominator, it's still there, and it's going to affect your answer. But now I can cancel out the k minus 2. So that's just a little trick I wanted to make you aware of. All right, have fun.